So here I have removed the back plate of this X housing. You can see the spindle is going into this housing that's set on the back side of this big block for the Y Z axis. And inside here, it's a bit hard to see maybe. I'll try to add some light here. Sorry if the light gets in. But you can see there's a spindle and there's a block. And over there's a turning center knob, and there's a belt, and then you have the motor here. It's a bit hard to see. I'll try to move the lights around so you can. Unfortunately, I can't get it to run at the moment. Or maybe I can. One moment I'll try to start a program and see if it so I better can understand the concept here. Is a bit different from any other machines that I've seen. Normally the motor will be installed out here and turning the spindle, and the parts in the center will be more or less fixed. But in this machine, the mechanics is placed here with the spindle and the drive and the motor. As you can see, this motor is a black plastic housing. There's a marking plate at the end, so I know what type of motor it is. It's a very, very good one. It's a 2.9 amp, and I believe that the motors down here don't have the marking. It's another brand, but I believe that it also is around the 2.9 amps in the size. So one moment I'll try to start the machine with a small program so you can see this is turning. One moment. So now you can see the spindle is not turning, even that it looks like it's doing, but it is actually the hub inside here. It's a bit hard to film this. So if I maybe later on will change the machine, so it's having it has this part removed, and then it has another beam up here to sit on the top here to give more height, then I think I'll use the traditional way of having a motor out here and not reuse this system. And the reason for that is that the spindle, if I move it up here, the spindle will be too short. This spindle is 24 years old, and I don't know how bad the worn is on the spindle and the bearings inside here. And I have checked to see if I can buy new center knobs for the ball screw in this design, and it's very expensive. So I don't think I'll reuse this way of doing the spindle on. But I must say, when the machine is with the dust cover on and this plate is installed, it's nice and pretty designed. There's nothing sticking out of the ends, and it's looking nice. So this is the inside house. It's having the cables and the coolant tubes coming out here and going to the front with the connectors you saw on the front side there. And this cable is here. This one is just a connector for the stepper motor. And it may be seen that in the video here it's looked like that the connector is fairly close and the cable is close to the spindle, but there's actually 5 centimeters or something. So you can see the build there. This small iron flange that's sitting here, it's simply to hold the dust cover in place. So if you move it over, I can just remove the dust cover by take it off this way. So now the machine is stopped, and I can hear from Mach 3 that it's because the limit switch had a random trigger again. Even that this program should be running for a lot longer than it actually did. So yeah, you can see at the moment there is no bracket on the to hold the cable chain. So this box is now hit by the cable, and down here it's now hitting in here. So it's when the car is moving back and forth, it's pulling in the dust cover. So the arm is holding it up here, and the dust cover is free, and the housing up there is free. So it's this dust cover I cut, this arm I have cut in on this machine. It's 5mm aluminium arm. I made some holes that was wrong, so this is why there are so many. There's actually only used this for and this for. This and this is wrong location. So it was a user error in the measurement. I planned to align it with the top line here, but I haven't calculated that if I align it up here, then this plate was too high and the chain was sitting like this because it was pulling the chain too high at that point. So I had to move the plate down. Yeah, I can't hold it up there at the moment, but it was sitting too high and I had to move it down. So this is why there's some extra holes in this bracket. So it was the X set housing for the center axis and the motor with the belt drive system that's sitting in here, and the funny way that it's designed on. There you can see the outlet for the coolant and the round connectors that was on the front is sitting over here. And here's a control valve for the coolant. If you see down there, there's a fairly big hole in the block. It's where the cables are going to the limit switches in front. So it's a bit hard to get the light in there. But you can see there's a cable going in there, and there's a light shining from the front. It's a bit easier to see here. So that's a nice big hole. This cable that's in at the moment is actually going in the hole and up. And that's the connector for the stepper motor in the front. And this holder here is where I will have the cables for the limit switches, the optical sensors I will place in the front. Here you can see the Mach 3 program. Where I have loaded the program that's making a squared box with round corners. It is 10 centimeters and 10 centimeters in the height. So until the machine go to 0. And now we can run this program. There's just doing the squared box with the round corners, and it's a fairly short program, but it's looping the program 100 times, so it's easy for me to start this program and see the machine running. It's the same movement over and over and over and again. So let's start the program. Let's see over here. You can see the program is a short program, but it's looping. At the moment is running at a feed rate 500. We could try change that to maybe 1,000 or something. So now we can start the program again. It's now waiting for the spindle to come on and then do the movement. So now the limit switch has triggered incorrectly. And that the issue I have with the machine is losing steps all the time due to this cheap controller. And there's a switch that's triggering randomly even when the machine is closed, standing still and not doing anything. It sometimes triggers the limit switch. The clicking sound you're hearing now is just the dust cover on the backside hitting the spindle. There's nothing wrong with the machine, it's just a plastic hitting the spindle. If the table is moving all the way out, this place will just compress over, so it will be shorter and place on top of each other. And there's place here. There's not an issue. Nothing will be squeezed together there. You can see if I pull it. And now it will move it back. Let's try stopping the program. And then ref all the homes switches, so I can see it now. It will not ref the Z axis because I have removed the switch, so the switch is disabled in Mac, so it doesn't know where the location is. I have to do that manually, but for the Y movement and the X movement up here, it will use the switches. So it's actually hitting this switch down here and then having this corner as 0.0. So when the switch is hit down here, it will set this at the correct location, even the spindle is up here. And this is because I like to have the table free and in front. So now you can see it's homing the X. I just move the set up so it doesn't move hit the spindle with that holding screw here. So you can see it's compressing the dust cover. And the dust cover is on the other side is fully expanded, so you can see the table is now moved to the front. I'll move it to the other end. You can see here the dust cover here is compressed in this end under the table, so it's not an issue. Here you can see when the table is moved all the way back, the spindle is not supported in this end, it's simply free in the air. So when the table is moving to the front here, the center the spindle nut is only going here. You can see it on the grease. It's stopping here. So there's any reason for them to have added the last thing and added a bearing here. It's working fine without. So I can tell it to rev home. So now it's free of the switches. I can tell it to do the homing again. So I think it's a nice system, this dust cover. And even the machine is 24 years old, and you can see the dust cover is all intact. Means that it's a system that is working, and there has not been any issues with it. The only thing I don't know is how much the machine has been used in the 24 years. Maybe it has been standing still for a lot of the time, but As you can see, it's best to have the table here in the front when the machine is at the home position, because then you can easily mount whatever you want to do. It's not smart if the table is moved under the x-axis, then you have to move it before you can mount anything. So now I can just hit the homing reference home, and then it will drive to this location. Now it's going in. And this is the home location, so it's easy to mount the workpiece. To rewire the machine and installing the new parts, I have got some cable and electronics. So first up is this roll of cable. It's 8 wires, 0.05 carat wires, and it has a sleeve protection shielding, and it's color coded, so it's a good wire for. I plan to use this first for all the sensors, so one cable could get up to the cars on the x-axis to the housing, and all the sensors can be connected to the one cable. So this is the 50 meters cable, so there's 8 wires, and the other one is this one. It is 4 wires and 1.5 square root, and you can see here it's also shielded, and 4 wires with or 4 cores with the numbers on each of them. This is for the stepper drivers, or for the stepper motors. So there's 50 meters of this cable. So for each stepper motor I will replace the cable with this cable, and there will be no issue holding the current, and it will be long enough, and it will be shielded. So that's some of the next steps I have to do, is replacing all the cabling inside the machine and make it to a better version. So for the electronics, I have the. Let's start with the optical sensors I like to use. You can see here, it's a slot sensor. So the part that's going into this slot will break the beam that's in there, and this is used for the machine. So this will be sitting up here somewhere, and this will go into this slot and break the beam, and that will go back as a signal to the controller. I have tested this sensor in a at home scene with a small setup. It's a very precise OMRAM sensor used for industrial machining, for getting the correct location. There's a different types of this. There's this slotted one with the mounting in top, small there. And there's this flat sensor. There's this style, and there's this style. So I got different type of them depending on how I wanted to mount the ones and where I will use them. So I think I will replace the macro switches, the mechanical ones, with the optical systems, because this will never break, because nothing hitting the sensor. It will just be some metal plate going into this slot, and if it's running too much, it will just drive by. It will not break this sensor. And also this sensor is very precise, and the repeatability where it will stop and detect the signal every time at the same location is very good. It's very good at detecting that. So that's the optical sensors that I plan to use. For the stepper drivers, I have this. There's 3 boxes here, 1, 2, 3, and the top one is this that is open. You can see this. It's a bit hard to see. Each showing EM806. This means the 80 means it can handle 80 volts of power, and I believe up to 6 amps. It's a fairly big driver, as you can see. So I plan to, with the big cabling, run the motors at 2.5 amps at maybe 60 or 70 volts with some very good power supply to make sure that the current is moved all the way fast and good up to the motors, and it's not the limit of the cable. The one thing that was a reason why I selected this driver was it seems to be a very good driver on the from reviews on the internet. It could have the 80 volts. It seems to be a very fast internal electronic that's using a DSP processor and can run at 200 kHz, whereas most other drivers is running a lot slower. And then the last reason was that it has a serial port. There's a small connector here with the cable, so you can plug into the driver. And what that is that you can program the driver with some software. And with this software, you can tell the driver to automatically detect the motors. And I have 2 motors that I have no markings on the motors, but I'm guessing what they are in size. So this will help me determine the settings for the motor by asking this controller to automatically determine the settings that's best for the motors, and hope that they are correct and that will overheat the motors and so on. But I will check that later on with a thermal image camera to see if the motor is getting too hot when running. It's a digital stepper driver, and seems to be very good at turning at a very low impulse, so it doesn't need much signal to register that it has to turn. So it should be a very good drive. It also have detection if it thinks the motor has stalled. So if it thinks the motor not can turn anymore, like if the motor has run into some obstacle on the machine, then this will automatically turn off and go into alarm mode. So if you see here, there's 2 pins for alarm. On here there's a diode for flashing. There's a green one for power and a red one for alarm. And the alarm one will signal that the driver has detected there's an error with this stepper motor. So instead of just getting the cheap eBay one, I selected this one for the option that it can help me determine the correct settings for the motor. It can run 80 volts. I can program the settings correctly and determine that with the computer. it has the alarm signal and stall detection. So even that on my machine there's a fairly big machine and can maybe damage itself if it's running into if a limit switch is not working and is running into the end of the machine and maybe damage the machine. But this will prevent it because it will turn off automatically if there's an error. And then I got some other boards from the CNC for PC website. I was looking for some breakout boards. The first one is this one. This one is called C50. Yeah, what's it? C5030. Yeah, it's there. If you can see it, it's a parallel board, and there's a RJ45 connector for each axis. You can see down on the board here there's a X, Y, Z and the A axis. This is for the motor connections up to the stepper drivers. So it's easy, if there's an issue with the board I can just unclick the connectors fairly easy and replace the board. And the cable up to here I can use some shielded cable, even that this is plastic but the cable can be shielded and connected to the chassis here. So I will have shielded wires going from the driver up to here. This board is not optical isolated, and there's no reason for it because the signal is just coming out here and then go up to the driver, and inside here there's optical isolation. So there's no reason to have it 2 times. And if I understand correctly, having too many optical isolation optocouplers in series, it can delay the signal and make it maybe too short. So it can be a reason for having a missing step or something like that. So it will have directly signals as a buffer driver built into this board. So it will automatically take the weak signals from the PC and make them to good signals that's coming out here and coming up to the drivers, and the driver will be having good input and not weak signals depending on this parallel port on the PC, what version that is. So there's a USB power cable that's going into, I think it's here or here. It's here in this side, like this over there, and that's giving the 5 volt power in, and this chips will make the signal coming from the weak side to get some strong signals outside. There's some inputs also I can use for limit switches, but I think it will be for primarily the emergency stops and other important switches that I will place on that board. Here's another board I plan to use. It's because I will not have enough input ports on this board, so I decided that I will use 2 parallel ports in the PC and 2 boards. This board can be used to have almost all inputs as almost all connection as inputs. So there's a jumper here where you can set the let me see, up there you select if on that jumper You select if the pin 2 to 9 is inputs or outputs, and I have set them so there will be inputs, so I'll get a lot of inputs on this board and the outputs on this board and some inputs and a few outputs also on this board. So this will mean that all the sensors I have, the limit switches, emergency stops, and maybe other sensors and things I didn't plan on yet, I will have on the two boards together have so many inputs and outputs, so it will work fine. When I was shopping for the boards at the website, I saw this board. This board is a small board that's called an index board. What it does, it has this small optical sensor. This is installed inside the spindle motor, and when the motor is turning, this sensor detects the spindle turning, and this board sends a signal back to the one input, and this telling the PC how many RPMs the motor is running at. So you can exactly at the PC see how many RPMs the motor is running. This is something I will try to install much later when I have all the other things fixed and installed. But when I was shopping at the website for the other boards and controllers and so on, I was just checking that board also. So that's the new electronics I plan to install, and it will be housed in that enclosure that I just showed you earlier. That will be in the back end of the machine, and there's the optical sensors that will be installed on all the axes instead of the micro switches and the cable as there. There's also here some this is a shield in a loose form, so I can, if there's some cable where I need to have extra shielding going over the connector or something, this is something that can be put in over, so I can cut a piece of this and connect in over, and so I can make sure that the shield is going all the way from the beginning of the connector and all the way out to the cable, and having a good connection to the shield here. It's just some extra ones that I ordered from the web shop. So that was my machine, and I have to do a lot of work on the machine to get it fully working. But as you can see, it seems to be a good machine that just needs some new parts and stuff, and when I've fixed all the things, I think it will be a very nice machine that can do all sorts of nice cutting and build funny things with it. So thank you for watching. Bye.